Hello boys and girls, this is Mr. Kizik, and in this video we're going to be talking about zeros of polynomials. But before we do that, let's just look over the homework here. So as you can see, hopefully you did draw the graphs on your graph here when you were looking at Desmos. So this was an even degree with an even degree with a negative leading coefficient. So therefore, it was an upside down U-shaped looking graph here. So that means domain again is all real numbers, and the range is, well, my highest value was 6.5. It was up here on the very top, and then it went below there. So y is less than or equal to 6.5. Now, the relative maximum. If you remember last class, I mentioned if something's a maximum, it's not a relative maximum, or a relative point, it's an extrema. Technically, though, it still is a relative maximum because it is a turning point. It is where the graph changes direction. So if you put it down, so like here, for example, negative 1.57, that was extreme, not relative maximum. But if you mark it down, it is still correct here. Then the other maximum is right over on the other side. Can I do it late? Ooh, I can. Cool. The other extreme was right here. Then the relative minimum, again, you're looking for a valley, so it was this point right here. The end behaviors, again, since it's an upside down U shape, it's both negative infinities as you approach x left and right. Increasing intervals, well, from left to right, I'm increasing as I'm going up here to negative 1.57. Then from there to 0.41, I'm decreasing. Then from 0.41 to 1.16, I'm increasing. And then from should be here. Yeah, right here. This is wrong. This should be 1.16. So 1.16 to infinity, it's decreasing. So 1.16, that should be. For number 4, we got an odd degree with a positive leading coefficient. So that just means then domain and range will be all real numbers. Relative maximum, again here, this is the highest point. And then relative minimum, right here, one of the lowest points. As x approaches infinity, so as x gets bigger, y goes to infinity. As x gets smaller to negative infinity, y gets to negative infinity. I'm increasing from negative infinity to negative 1.2. Then I decrease from there to 1.5. And then from 1.5 to infinity, I increase. Right? If you got any questions, just let me know. Shoot me an email, and I'd be happy to answer you. So now today in class, you should have gotten this. Oh, I gotta get my point back. There we go. Come on. Alright. You got in class this packet with zeros. And a lot of this should be familiar with you guys because we have talked about it already. So what are zeros? If you remember, zeros are the point or points at which the function intersects the x-axis. Now, what's nice about polynomials, when you look at the highest degree of the polynomial, so the degree of n, it can have at most n real zeros. So if, say, the quadratics we've been doing, when it's x squared, that means it can have at most 2 real zeros. It could have less, but it cannot have more. An even degree polynomial has an even number of zeros, or no zeros, because remember 0 is an even number. And a polynomial that has an odd degree has an odd number of zeros. Now, the problems that we are going to be looking at now, they're going to have real zeros. Eventually, we're going to be looking at ones that have non-real zeros or imaginary zeros, but it still satisfies these definitions or rules here. So one way to identify the zeros is looking at a graph. So if I look at number 1 here, x cubed plus x squared minus 2x. If I go to Desmos, which let's do that right now. Let's see, x cubed plus x squared, what was x squared, minus 2x. All right. So it looks something like this. So I would draw this on your graph paper. And then we're going to look at where does it cross the x-axis. Well, what's nice about Desmos again is that where these dots are crossing the x-axis, those are your zeros. So right here, here's my x-axis. It crosses at -2, at 0, and 1. So my answer is going to be, if it pops back up, there you go. So we know -2, 0, 1. It looked something relatively like this. I know it's not exact, but so right here is where the zeros were. So x equals -2, 0, and 1. Alright? That's all you're doing when you're looking at the graph. You're just looking to see where does it cross the x-axis. So let's just look at another one. Let's look at number 2. Number 2 says negative x to the 4th, negative x to the 4th, plus, I think it was 3x cubed. Let's just go back and check. Nope, plus 4x cubed. Sorry. That's 4x cubed minus 2x squared minus 4x, and that was plus 3. Yeah, plus 3. Alright, so there you go. We knew it was going to look like this here because it's an even degree with a negative leading coefficient, so we knew it was going to be upside down u. But again, we're going to look at the dots to see where it crosses the x-axis. It crosses the x-axis at -1, 1, and 3. So -1, 1, and 3. I'm just going to, again, -1, 1, 3. So that was like something like this. Again, I'm not drawing it to scale, but you get the gist. So here, x equals -1, 1, 3. Alright. So graphing is not too bad here. But how about if you don't want a graph, you don't have a graph paper or Desmos with you here, what else could you do? Well, you can also factor the polynomial that's given and then set each part equal to 0 and solve for x. Remember, just like what we did before with quadratics. So if I look here, it says write f of x equals x cubed minus 2x squared minus 15x in factored form. All that means is, factor out this polynomial. So if you recall from when we did this, what's the greatest common factor, if any, of this polynomial? And you'd be correct in saying I can factor out an x from each term. So I'd have x, and then what's left over? X squared minus 2x minus 15. And now this part here in the parenthesis becomes factoring your quadratic. What two numbers multiply give me -15, and those same two numbers add to give me -2. And hopefully you figured out that those two numbers are -5 and +3. So then this becomes x times the quantity x minus 5, x plus 3. So now all you're going to do is to take each term here, each thing in the parentheses, and set it equal to 0. Well, this one right here, the first one, the only way that could be 0 if that's 0. I'm going to set x minus 5 equal to 0, so x is going to be 5. And I'm going to set x plus 3 equal to 0, and x equals -3. So my zeros are x equals -3, 0, and 5. Alright? So I can also factor out to see where my zeros are located. Now what's important about these zeros here? Like, why does it matter? Well, if we were trying to draw it out, identifying the zeros can tell us the multiplicity of it, which basically means how many times does that 0 occur here, as it says right here. So if I look at number 4, write this in factored form. So again, is there a greatest common factor? And there is. I can factor on x. So I have x, and then left over x squared minus 6x plus 9. Again, what two numbers multiply give me positive 9, and those same two numbers add to give me negative 6? You would say negative 3 and negative 3. So x minus 3, x minus 3. I'm also going to rewrite it like this just to show you guys something. And hopefully you can see that I can write it as x minus 3 quantity squared because it occurs twice. So again, I'd set each one equal to 0. So this is 0 here. X minus 3 equals 0. X is 3. X minus 3 equals 0. X is 3. So what are the zeros? Well, x equals 0. That's one of them. What's its multiplicity? Basically what it's asking for is how many times is x 0 here? Or how many times is the value of 0 occurring? And it only occurs once. Right? I only have x equals 0 once. So its multiplicity is 1. The next one we got x equals 3 was another 0. Well, how many times did we get that? We got it 1, 2. So its multiplicity is 2. And so in this portion here in the middle, I had it all stretched out, broken down for you. But when I condensed it, look at the degree here. That degree told me that the 0 of 3 occurred twice. So, what do the zeros and the multiplicity have to do with each other? There is a correlation. And the correlation is how it affects its graph. So let's actually, we're still doing the same polynomial, x cubed minus x squared plus 9x. Let's actually see what that graph looks like. So let's go back to Desmos. X cubed minus 6x squared plus 9x. Let's see what this graph actually looks like. So it looks something like this. It looks like, again, it's an odd degree with a positive coefficient, so it's a wave kind of thing. Draw this out here in a graph. And again, we'll do a little rough estimate. 0 was one of the zeros, and 1, 2, 3. So it looks something like this, roughly. Look at where it crossed or touched the x-axis. When x was 0 right here, it crossed because it had a multiplicity of 1. Whereas here, when x was 3, it bounced off it and the multiplicity of 2. So therefore, if the multiplicity of a 0 is odd, then the graph crosses at the 0. Just like it did here. 0 was a multiplicity of 1, it crossed. Whereas if the multiplicity is even, then the graph bounces at that 0. Just like it did here with x equals 3. The multiplicity was 2, it went down, it got to it, but then bounced straight back up. So let's look at some examples of identifying the zeros and the multiplicities and what the effect it will have on their graphs. So if I look at number 6 here, it's actually already factored out for you. So you're going to set each parentheses equal to 0. X plus 7 equals 0, so x is going to be negative 7. So negative 7 is a 0. Well, what's the multiplicity? Well, if I look at the degree with that parentheses, it's 2. So therefore, the multiplicity is 2. And because 2 is an even number, it's going to bounce off at that point in the x-axis. Let's look at the next parentheses. 2x plus 1 equals 0. If I solve for it, and you guys can do that, x is going to be negative 1/2. Okay. what's the multiplicity there? Well, there is no exponent with that parentheses, so it's 1. And since it's odd, it's going to cross at that point at the x-axis. And the last one, x minus 4 equals 0. So x is going to be, just write that, x minus 4 equals 0. So x is going to be 4. So that's my other 0. The degree here, the exponent, is 3. And because it's an odd exponent, it will also cross there at the x-axis. Let's look at number 7. So this one we got to factor because there is no parentheses here. So first we want to do is, what's the greatest common factor of x to the 4th minus 2x cubed minus 8x squared? Think about it for a moment. Hopefully you figured out that the greatest common factor is x squared. And then what's left over? X squared minus 2x minus 8. And then again, the parentheses is going to become what two numbers multiply to give me negative 8, and those same two numbers add to give me negative 2. And that's going to be negative 4 and positive 2. So x squared, negative 4, positive 2. And then you set each thing equal to 0. So this portion here, x squared equals 0, x is going to be 0. But what's the multiplicity? Well, here's the degree right here. Degree says 2. It's even, so therefore it bounces. I'm going to set these equal to 0, each parentheses equal to 0. Solve for it. This would be x equals 4, x equals negative 2. 4, negative 2. Since the degree here for each parentheses is 1, I can't simplify anymore. And since both of them are odd, they're going to cross the x-axis at those points. And if you don't believe me, you could type in this into your graphing calculator or Desmos here, and you'll see at 0, it's going to bounce off there. At 4, at x equals 4, it's going to cross there. And at x equals negative 2, it's also going to cross there. Alright, the last problem we'll look at here is, let's work backwards. I tell you the zeros and the multiplicity, and let's write the function here. So a polynomial function has a 0 of negative 6. 0 of negative 6. So how do I write a parenthesis? In other words, basically what it's saying is, how do I write a parentheses x plus minus something equals 0, so that when I solve for it, you're going to get x equals negative 6. So what do I need at this portion right here in order for that parentheses to be true? Well, in this case here, it would have to be a plus 6, correct? Because if I subtract 6 on both sides here, I get x equals negative 6. So my first parentheses is x plus 6. The second part here says, let me write this function better. So f of x equals x plus 6. Then the next portion says multiplicity of 2. Well, that means negative 6 occurs twice. So let's write an exponent of 2. And then the next part says and 2 with a multiplicity of 1. So again, I need to figure out what is my parentheses so that when I solve for it, I get x equals 2. Well, that's going to be x minus 2. Multiplicity of 1. So that means there's a known 1 right here on the top. And then that's it. And this is in standard form from highest exponent to lowest exponent. We are done. Right? So zeros and multiplicity go together. They tell you how the graph looks like. So now we're starting to get that middle part of our graphs. Alright, so if you got questions, you shoot me an email, let me know. Ask someone else in the class too, if they understand it. Alright, so your homework is going to be all the problems here. I want you to do front and back, 1 through 10. Okay? So 1 through 6 is basically what we did here with the table. 1 and 2 are already factored out for you, but 3 through 6 you have to factor out yourself and then solve them. 7 is the working backwards, like the one we just did. 8, the same thing too. Now 9 and 10 is like what you had for homework due today, except we've got one new thing out of here. What are the zeros? So now we're going to get a nice looking graph. We're going to see that middle part there. What happens exactly? Where does it go up? Where does it go down? All right. Remember, if you got any questions or concerns, please feel free to ask me. This is Mr. Kiesik, signing off.